सबसे पहले इम्पोर्टेंट है आज के एक्सपेरिमेंट का ऑब्जेक्टिव और एम समझने की कोशिश करते हैं। आज हमारा क्या एम है, हमें क्या करना है। इम्पोर्टेंट है टाइम रिस्पॉन्स ऑफ आरएलसी नेटवर्क। आर रजिस्टर को बोलते हैं, एल इंडक्टर को बोलते हैं और सी कैपेसिटर। So basically the resistor, inductor and the capacitor are the essential part of any network. If suppose we have a circuit, then exactly it must contain at least one of these elements, and obviously most of the circuit contains all of the combinations: resistor, inductor and capacitor. Now talking about, if suppose we are giving some voltage, we are giving some supply to it, so it might be possible that you have some flow of current through the circuit. Exactly, might be possible कि circuit में current flow करेगा. In such situation when this kind of a current flow of the circuit is there, then one important aspect comes in a picture is time response. Time response, that means resistor, inductor and capacitor, they both allow to flow of current through them, but not immediately. Everything takes a little time. Everything takes a little time to start up a current. And that particular effect is called basically a transient time or time response. Transient time का example if you see here in your daily life, so you may find out like जब आप अपने घर में एक बल्ब को ऑन करते हैं और एक ट्यूबलाइट को ऑन करते हैं, तो यू सी योर इलेक्ट्रिक बल्ब गेट्स इमीडिएटली ऑन. मतलब इतना प्रिसाइज टाइम, you cannot just measure it out, you cannot just figure it out how much time it takes to get it on. But ट्यूबलाइट को जब आप ऑन करते हो तो you see it takes a little time. Similarly, if you see your fan, obviously your fan takes a little time to get its full speed. And one more example, you're going to start your AC, your air conditioner. So when you're going to start your air conditioner, immediately it doesn't get a start. It need to maintain some voltage to start up the condenser or the main compressor unit. So ultimately, the time taken to give its stable response is called as a transient response or time response. तो रजिस्टर इंडक्टर कैपेसिटर में भी यही होता है. जैसे बल्ब इज एन एग्जांपल ऑफ रजिस्टर, प्योर रजिस्टर, एक प्योर रजिस्टर है. सो रिस्पांस टाइम इज टू हाई, तभी इलेक्ट्रिक बल्ब इमीडिएटली ऑन हो जाता है. बट टॉकिंग अबाउट द एलएनसी, इंडक्टर एंड कैपेसिटर, द चोक कॉइल, ट्यूबलाइट के अंदर जो चोक कॉइल होती है, इट टेक्स अ टाइम टू गेट चार्ज. ये चार्जिंग का जो प्रोसेस है, इट इज कॉल्ड द टाइम. उसके बाद अपना ये फुल रिस्पांस. So this is a very very simple experiment we are going to work today, and this experiment is basically related with the response, how the resistor, inductor and capacitor are going to work with this. So this is all about the aim we worked upon. We have a vast theory of this, so I'm not just going to pick a lot one, but simply just giving you an idea. Like suppose you have any circuit, कोई भी अगर circuit आपके पास में है, so that circuit is basically consisting of three components. if तीनों अगर series में R, L और C लगे हुए हैं, I'll show the circuit to you. I'll show this kind of a circuit. Circuit में if you have R, L and C component, तीनों component अगर आपके पास में है, so total voltage will be given by R I, and the current through the inductor will have a equation di by dt. मतलब it is not Li, it is L di by dt. मतलब change. So inductor only reflects if there is a change. If there is no change, it doesn't reflect. Third one is 1 upon C I d by dt. It means it has a number of changes of the current and that has a sum up. So this is the main equation. I suppose this is a very, very common and simple equation one must know. And this equation is called as a transient response equation. So Vi, Ri, L di by dt, 1 upon C. So Vi is input voltage. Input voltage can be written as. So this is the voltage across resistance. This is the voltage across inductor, and this is the voltage across capacitor. So under this situation, if we go for, so we have a large number of options to find out this one. So here we can calculate through this process what will be the frequency of oscillations. We can calculate अगर कोई wave है तो वो damp कितना होगा. That exactly we are going to work with this one. So now if you see this particular diagram, this is the main important diagram we are going to work here. This shows, if you say this is variation is not the input, ये input variation नहीं है, ये response variation है. जैसे एग्जांपल लेते हैं एक ट्यूबलाइट का. If you see the tube light, what happens in tube light? In tube light, it gets on, flickerings are there. That flickerings you show that it tries to start. ये कोशिश करती है start होने की, and it makes it on, off, on, off, on, off. For a period of time when it is making it on and off, that means at that time it is deviating from its output. मान के चलो अगर किसी भी सर्किट का आउटपुट इज 1, इज अ कॉमन आउटपुट इज अ 1, तो इस 1 के अबाउट इट मे हैव अ डेविएशन, हाई एंड लो, हाई एंड लो, वी हैव अ डेविएशंस. ये जो डेविएशंस हैं ये मतलब एक उसको पहुंचने की कोशिश करता है. दिस डेविएशन इज बेसिकली कॉल्ड एज अ ट्रांसिएंट टाइम, and it has a different type of values so related with this one ki how much it is going to be, but after some time it settle down. कुछ टाइम बाद ये अपना नेचुरल रिस्पॉन्स ले लेता है और इट बिकम्स अ कांस्टेंट. फ्लिक्स है ट्यूबलाइट के तो एकदम से लगता है ट्यूबलाइट तेजी से जली, so this shows that upper part deviating maximum than the required output. जितना आउटपुट चाहिए उससे ज्यादा गया, सिंपली कमिंग अप टू द लोअर साइड, फिर दूसरी साइड ऑफ हो गया, फिर हाई, फिर ऑफ, फिर लो, and then finally slowly it is adjusting. So you can say like it is also like a pendulum. पेंडुलम में आप उस पेंडुलम को स्टेबल करना चाहते हो तो आपने उसको सिर्फ छोड़ दिया. इट शोज लाइक दिस शोज दैट काइंड ऑफ अ मूवमेंट इन अ पेंडुलम. ये मूवमेंट होगा, धीरे धीरे कम हो जाएगा एंड फाइनली इट गेट स्टेबल. यही बेसिकली कॉल्ड इट ट्रांजिएंट रिस्पांस. एंड ट्रांजिएंट रिस्पांस में स्टेडी स्टेट रहती है. दो रिस्पांस होती है, एक तो ट्रांजिएंट जिसमें वो बदलता रहता है, परिवर्तित होता है, और सेकंड होती है स्टेडी जिसके बाद वो कांस्टेंट हो जाता है. तो पेंडुलम को अगर आपने छोड़ दिया तो पेंडुलम एक बार से एक बार जब तक ये ऐसे कर रहा है तब तक वो कहलाएगा ट्रांजिएंट रिस्पांस, लेकिन एक बार जैसे ही कांस्टेंट हो जाएगा स्टेडी स्टेट. Everything, every different kind of a system has a steady state and as well as the transient response. So let's see what we are going to do with this experiment. इस experiment में हमें क्या करना है? So we are coming on the simulation part. We see a very simple case we have taken. A resistance R. You have an option to change the values according to your choice. You can change your values. We have inductor. We can change the inductor value. We have capacitor. We can change this capacitor. And here we are providing certain voltage V input that you can also change आप अपनी मर्जी से, and simply you have this output voltage across the capacitor. So see here, nothing we are going to do. We are providing a voltage input and try to find out कि capacitor के across voltage जो होगा starting में change होगा तेजी से फिर बदलेगा. So let's see what will be the response comes in this. So we are simply solving and checking that what will be the current. So here we are having the current in the circuit because this is a series kind of a circuit. So current starting में, if you see here, starting में तेजी से बढ़ेगा. It shows you all these values. They're showing up here. And this is with respect to time. And here we have this current value and current values with respect to what? Time. सर्किट के अंदर तेजी से करंट पहले बढ़ेगा और बढ़ने के बाद फिर स्टेबलाइज होता चला जाएगा और सर्टेन वैल्यू पे जाके ऑलमोस्ट एक फिक्स वैल्यू पे चला जाएगा. दिस इज एग्जैक्टली कॉल्ड एज अ ट्रांजिएंट रिस्पांस ऑफ करंट. ऐसे ही आउटपुट वोल्टेज के बारे में बात करते हैं. इनिशियली इफ यू सी हियर इट शोज हाई पीक, shows high peak, it increases the value, and then after a period of time it becomes almost that exactly the same one. And by entering this value you can verify this one, you can check your values, how much value you are going to put. This all results will come up here through this verification process. So you see what else you can do. You can increase the value of this one. Let's say instead of putting this one, this can be written as 5 volt. And now try to solve this one. So you see we'll have a different values that will be going to change. Your different values change. You can change the value of resistance. We're going to change this value resistance of, suppose I'm putting it as 10 and putting this value point instead of 0.25, let's say it's 0.5. Just cap this value here. And 3 instead of this, I'm just changing it. And finally, I'm solving it. So you see here, the response has been changed. So now this current is initially rising up and then after becoming almost constant. So this is exactly the process. Because you know what happens? Why this current is getting zero? Ab important point, current zero kyun ho raha hai? So if suppose we are watching it, we are providing a DC supply. And the DC supply has a response for the resistor. DC supply has a response for the inductor. But talking about this capacitor, you have already studied कि capacitor जो होता है that exactly XL equals to 1 upon 2 pi FC. X equals to 1 upon 2 pi FC. And this 1 upon 2 pi FC tells अगर frequency 0, DC की frequency 0 होती है. It tells you अगर frequency 0 है, in that situation XL will become 0. और अगर XL 0 हो जाएगा, infinite हो जाएगा, infinite resistance जहां पर, तो उसके through current 0. Capacitor important है. This is very important term and you must know that. You all must know that. हमेशा सबको पता होना चाहिए. When capacitor is connected across a DC supply, जैसे capacitor को किसी DC supply के across लगाया जाता है, initially it starts flowing a current. शुरू में थोड़ा सा current flow करना start करता है. But as soon as it charged, immediately current drops. फिर ये current नहीं लेता supply से. This is exactly the phenomena of capacitor. If you change this value, let's say making this 0. Now capacitor has a 0 value. Let's see what happens here. No response because capacitor is not getting any values from the charging. कोई charge नहीं होगा, कोई output response नहीं है. And as you change the value of this capacitor, जैसे आप इस capacitor की value को change करते हो, you are making it like a 0.25. And that situation we see here, you are having a maximum required current is, this is the amount 0.38. So here on this is a time scale. So at this second 1.068, if you see here, this is 1.0875. At 1.0875 second, it immediately gets a maximum value. ये maximum value receive करेगा. And if you see here in 11.4625, or you can say like here 9.8 point, it will become almost 0. So it will get completely charged in 14 seconds. So this shows you here. And if suppose you change the capacitor value, let's say we are changing this 0.3. So a capacitor with value of 0.3 is having this situation. Now this is getting changed. So it is taking more time. Simply, if a capacitor with value, I'm increasing too much, making it 0.8. See, now it's just taking more than 29 seconds to get completely charged. This is exactly the transient response. And once it becomes charged, then it requires no current, the current will become 0. This is today's experiment. Actually, in this case, time response is very important to know the system behavior. How much time will it take to perform? Like बहुत सारे examples होते हैं. जैसे आपके घर में एक simple blower, room heaters जो होते हैं. So you are making it on, immediately you are getting the maximum heat. Not at all. You are not getting immediately the maximum heat. You, whether it is a convector, whether it is a simply kind of a rod base is there, heater is there. So it is taking a little time to make its own surface hot. Then it is taking time to make your room hot. So this is the response behavior. Here in this case, हमने capacitor लिया हुआ है. The capacitor is basically having a property. Capacitor की property होती है. What's that property? The capacitor is basically having a property that जब इसको DC supply के cross लगाया जाता है, it receives current, it draws current from the supply. Supply से current draw करता है और it makes the circuit complete and get charged और charge हो जाता है. Once it becomes completely fully charged, ना इसकी कैपेसिटी है, जो भी इसका चार्जिंग कैपेसिटी है, once it becomes fully charged, then after it stops receiving current from the source. ये source से फिर current नहीं लेता. In this situation, it works like an open circuit. और जब open circuit की तरह behave करेगा तो current zero हो जाएगा. So here हमने कैपेसिटर को एडजस्ट किया, एक RLC सिंपल सर्किट बनाया और DC सप्लाई दिया और चेक किया how much time it is taking. So we got that 0.8 के लिए तो इतना ज्यादा टाइम ले रहा है कि basically it is not charged completely और टाइम चाहिए. लेकिन अगर इसी वैल्यू को लेट्स से हमने इसको 0.5 किया and then trying to find out this one. So we got that okay, approximately in 25 सेकेंड में अगर आप एक 0.5 माइक्रोफैरेड का अगर ले कैपेसिटेंस इन फैरेड, सो अगर आप 0.5 फैरेड का कैपेसिटर लेके आते हैं तो 0.5 फैरेड का कैपेसिटर जो है आपका वो आपका अप्रोक्सीमेटली 25 सेकेंड में कंप्लीटली चार्ज हो जाएगा. दिस इज एग्जैक्टली. एंड दिस पर्टिकुलर ट्रांजिएंट रिस्पॉन्स शोज कि इसका करंट मैक्सिमम कितना तक चला जाएगा. ये 0.41 एम्पियर तक का करंट ड्रॉ करेगा. 0.41 एम्पियर तक का करंट ड्रॉ करेगा. उसके बाद में ये चार्ज हो जाएगा. धीरे धीरे करंट का वैल्यू डिक्रीज करेगा. तो ये इसकी यूटिलिटी. So before connecting a capacitor in fan, before connecting a capacitor in your AC, before connecting a capacitor in your heater, all over places at all over the positions, it is seriously required that all of these should be known previously, that what will be their response behavior. इसी हमें पता हो जाना चाहिए कि हमारा response behavior कितना है. ये यहाँ पर जो है वो मेन कंसेप्ट है. That exactly the